In this video, we're going to discuss two special cases for factoring. We're going to talk about factoring perfect square trinomials, and we're going to talk about factoring the difference of squares. So we're going to go ahead and start with the perfect square trinomials. And here are the steps. So the first thing that we're going to do is we're going to check for a GCF, greatest common factor. Then we're going to make sure the trinomial is written in standard form, which is ax squared plus bx plus c. We're going to make sure the first and last term are both perfect squares. And the middle term must be equal to the product 2 times, and this should be the square root of AC. All right, our formula, if I have ax squared plus 2ac times x plus c is equal to ax plus c quantity squared. Just as a side note, if you don't recognize this pattern, it's okay. You can still factor these trinomials using the previously discussed strategies for factoring trinomials, and you'll get the same answer. All right, so question number 1, I have v squared plus 2v plus 1. First thing I'm going to do is check to see if my first term is a perfect square. So the square root of v squared is v, so that is a perfect square. And I'm going to check my last term, 1. Square root of 1 is 1, so that's also a perfect square. And then I need to check my middle term. Is my middle term twice the square root of a squared, the first term, times the square root of the last term? And 2 times v is 2v, times 1 is 2v. So indeed that matches. It checks out. It works. So when I factor this, my factor is going to be v plus 1 quantity squared. All right, example 2. I'm going to check my first term. I have 16k squared. Is that a perfect square? Absolutely, because the square root would be 4k. Check my last term, 25. Absolutely. Square root of that is 5. And then I'm going to look at my middle term. Is this twice 4k and 5, that product? And now, I have a negative 40 here in the middle. Don't forget that the square root of 25 can either be a plus or minus. And in this case, we're going to need to look at the negative version, as this is a negative connecting the first term and the second term. So if I multiply these together, I have 2 times 4k is 8k, times negative 5 is negative 40k. Matches, checks out. So my answer is going to be 4k minus 5 quantity squared. So again, 4k minus 5 squared. All right, example 3, I'm going to check my first term and my last term. So I have the square root of 4p squared. That is indeed a perfect square. It should be 2p. And then check 9. Square root of 9 is 3. That absolutely works out. My term here in the middle is positive, so I'm going to use the positive root of the constant. So I'm going to use a positive 3. And then I'm going to check my middle term. So 2 times 2p times 3. And again, the 2p comes from here and the 3 comes from here. Multiply those together. 2 times 2p is 4p. 4p times 3 is 12p. That was what I was looking for in the middle. So my final answer, 2p plus 3 quantity squared. Last example of a perfect square trinomial. I'm going to check for a GCF, and in this case I have one. I have a greatest common factor of 2. So 2 times 4x squared, I'm going to factor this out, so minus 12x, and 2 times 9 gives me 18. So I have to remember to check for a GCF first. All right, so now I'm going to check my term here. I'm no longer using this. I'm going to check my trinomial in the parentheses. So my first term is 4x squared, which is a perfect square. Square root would be 2x. 9 is a perfect square. Square root is 3. I have a subtraction sign here, so I'm going to use a negative root. And then I'm going to check for twice 2x minus 3 to see if that matches. 2 times 2x is 4x, times negative 3 is negative 12x, which is what I needed in the middle. So that means my final answer is going to be 2. I have to remember the GCF. and then 2x minus 3 squared. All right, moving on to difference of squares. So this is another one where you have a special case. So steps for that, I'm going to check for a GCF. I'm going to make sure the binomial is written in standard form. So highest exponent first, followed by the constant. There will be no middle term. The first term and the last term must both be perfect squares, joined by a subtraction. The middle term must be equal to 0. So my formula, if I have ax squared minus c squared, I can factor that into a plus c times a minus c. This one's a little bit trickier to use our standard methods for, so this is a good one to recognize as quickly as you can. And this is always going to be a binomial, so it should be pretty simple to recognize. All right, so my first example here, number 5, I have n squared minus 25. So the square root of n squared is n. The square root of 25 is 5. So my two factors are going to be n plus 5 times n minus 5. Number 6, my first factor, or my first term is 9v squared. So the square root of 9v squared is 3v. My constant is 16. Square root of 16 is 4. So my two factors are going to be 3v plus 4 times 3v minus 4. Number 7, my first term is 9n squared. So if I take the square root of that, I'm going to end up with 3n. My second term is a 1. So I'm going to take the square root of 1 and I get 1. So that means my two factors are going to be 3n plus 1 times 3n minus 1. Last example, number 8, check for a GCF first. And in this case I have one, it's 5, so I'm going to factor out the 5 and I'm left with a squared minus 9. I'm no longer looking at that first binomial, I'm going to use my factored version. So my first term here is a squared, square root of a squared is a. My constant is 9, so square root of 9 is 3. So my factored form, I have 5 times a plus 3 times a minus 3.